Hello and welcome to all students. In this lecture, we learned about partial derivatives. So first of all, we define what is meant by partial derivatives. Before studying the partial derivatives, we recall what is meant by derivative and what in 12th standard we studied a simple derivative, the derivative of a function of single variable. Derivative of function of single variable. Now in this unit we will study about derivative of a function of several variable. So when function is a function of single variable, when we find its derivative, it is called as a simple derivative or a total derivative, ordinary derivative. And when the function is a function of several variable, and if we find the derivative of that function, then that derivative is called as a partial derivative. Okay, so we study about the partial derivative, and first of all we define what is meant by partial derivative. We see the outline of our lecture. In this lecture, first of all we define what is mean by partial derivative, then we write some remarks on the partial derivative, then we see some examples on partial derivative, and then we see the algebra of partial derivatives. Okay, so this is the outline of our lecture. So first of all we define what is mean by partial derivative. Let capital S be any non-empty subset of Rn. Capital S be any non-empty subset of Rn. S must be a non-empty and it is a subset of Euclidean space Rn. Let f is a scalar valued function from the set capital S to the set of real numbers. It is a scalar valued function. Let a is equal to a1 comma a2 comma dot 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 comma an belongs to S, be any point in set S, or we can say any vector. We call it is point here now. Be any point in a set S. The partial derivative of f at the point A with respect to ith coordinate is denoted by notation dou f by dou xi of A, or we can read it as dou f by dou xi, or partial derivative of f with respect to xi at point A, and it is defined as dou f by dou xi at point A is equal to limit h tends to 0 f of a1 comma a2 comma dot 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 ai plus h comma dot 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 an minus f of a1 comma a2 comma dot 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 an whole divided by h. So this is the definition of partial derivative of function f with respect to ith variable xi at point A, provided that the limit on RHS exists. हे जे राईट हँड साईडचं लिमिट आहे ते एक्झिस्ट झालं पाहिजे. जे एक्झिस्ट असेल तरच आपण काय म्हणणार आहोत, पार्शियल डेरिव्हेटिव्ह ऑफ फंक्शन एफ ॲट पॉईंट ए विथ रिस्पेक्ट टू एक्स आय एक्झिस्ट. ओके, तर नोटेशन जे आहे पार्शियल डेरिव्हेटिव्हचं, त्या नोटेशनला डिनोटेड बाय दॅट नोटेशन इज डो एफ बाय डो एक्स आय असं रीड करा, किंवा डॅबा एफ बाय डॅबा एक्स आय असं रीड करा, किंवा डायरेक्टली वी कॅन रीड इट ॲज लाईक दिस पार्शियल डेरिव्हेटिव्ह ऑफ एफ विथ रिस्पेक्ट टू एक्स आय ॲट पॉईंट ए. अशा पद्धतीनं तो पार्शियल डेरिव्हेटिव्ह रीड करायचा आहे. आता या डेफिनेशनमध्ये पार्शियल डेरिव्हेटिव्ह ऑफ एफ विथ रिस्पेक्ट टू एक्स आय ॲट पॉईंट ए इज इक्वल टू, इट इज नथिंग बट ए लिमिट एच टेन्स टू झिरो. तर लिमिट घेताना काय केलेलं आहे बघा, इट इज अ लिमिट ऑफ कोशंट. कोशंटमध्ये न्युमरेटरमध्ये काय आहे, तर फंक्शन एफ. So in the numerator there is a subtraction of two things. First thing is f of a1 comma a2 comma dot 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 ai plus h comma dot 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 an minus value of function f at point a, means f of a1 comma a2 comma dot 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 an, and divided by h. Okay, so this is the definition of partial derivative with respect to partial derivative of f with respect to ith variable xi. Okay, definition is very important, we keep in mind. Now we write some remarks. First remark is partial derivative of f at partial derivative of f with respect to xi at point a are also denoted by di f of a or fxi at a. There are two more notations to denote the partial derivative of function f with respect to xi, with respect to ith variable xi at point a. So there is one more notation, di f of a or f xi at a. So keep in mind this notation also. So second, next remark is partial derivative of f with respect to xi at point a is in fact the directional derivative of f at point a in the direction of the vector ei is equal to 0 comma 0 comma dot 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 comma 1 comma dot 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 0. तर बघा इथं पार्शियल डेरिव्हेटिव्ह ऑफ फंक्शन एफ ॲट पॉईंट ए विथ रिस्पेक्ट टू द व्हेरिएबल एक्स आय, it is also known as the directional derivative of function f at point a in the direction of ith unit vector. This is vector ei जो आहे तो ith unit vector आहे तो. ओके, तर partial derivative आणि directional derivative they are quite one and the same. Okay, one and the same. So here partial derivative we are taking partial derivative of function f with respect to the ith variable. It is same as finding the directional derivative of function f in the direction of ith unit vector at point a. If f is a function from R2 to R is a function f of x comma y of two variables x and y, we denote the partial derivative of f with respect to variables x and y at point a1 comma a2 in R2 as, first of all we write the partial derivative of function f with respect to x like this. Partial derivative of f with respect to x at point a1 comma a2 is equal to limit h tends to 0 f of a1h comma a2 minus f of a1 comma a2 divided by h. So this is the definition of partial derivative of f with respect to x in R2. Now second, we write the partial derivative of function f with respect to y at point a1 comma a2, and we write the notation like this: dou f by dou y at point a1 comma a2 is equal to limit k tends to 0 f of a1 comma a2 plus k minus f of a1 comma a2 divided by k. आता या दोन डेफिनेशनमध्ये तुमच्या लक्षात येईल, पहिल्या डेफिनेशनमध्ये आपण जो एच व्हेरिएबल आहे तो फर्स्ट कॉम्पोनंटमध्ये ॲड केलेला आहे आणि दुसऱ्या डेफिनेशनमध्ये आपण के व्हेरिएबल घेतलेला आहे जो की आपण सेकंड कॉम्पोनंट A2 मध्ये तो ॲड केलेला आहे. बरोबर आहे. तर एक्स कमा वाय, एक्स हा फर्स्ट कॉम्पोनंट आहे, वाय हा सेकंड कॉम्पोनंट आहे फंक्शनचा. एफ ऑफ एक्स कमा वाय याच्यामध्ये जी आर्ग्युमेंट आहे एक्स कमा वाय, जो पॉईंट आहे एक्स कमा वायचा, एक्स हा फर्स्ट कॉम्पोनंट आहे, वाय हा सेकंड कॉम्पोनंट आहे. तुम्ही ऑब्झर्व केलं तर या दोन डेफिनेशनमध्ये जर तुम्ही काय सिमिलॅरिटी आणि काय डिफरन्सेस आहेत हे याचा जर विचार केला तर हे दोन्ही फॉर्म्युले तुम्हाला लक्षात ठेवायला सोपी जातील. ओके. So first of all, we have written the definition of function partial derivative of f with respect to x at point a1 comma a2, and secondly